Assalamu alaikum. Welcome to Solar Tech. Solar panels 12 different type of losses which can lead to less generation. Incident angle modifier loss, soiling loss, light induced degradation loss, module quality loss, mismatch loss, module degradation loss, ohmic wiring loss, connection loss, system availability loss, potential induced degradation loss, inverter loss, inverter clipping loss. Incident angle modifier loss. Incident angle modifier loss occurs due to the tilt and orientation of the panels. The amount of solar radiation incident on a tilted module surface depends not only on the power contained in the sunlight but also on the angle between the module and the sun. The power density will always at its maximum when the PV module is perpendicular to the sun. Therefore, it is always recommended to install the PV module at an optimum tilt angle and in the northern region. The solar panels should always face south. Soiling loss. As the name suggests, soiling loss occurs due to the accumulation of dust and dirt particles on the surface of PV modulus. It depends on the cleaning frequency and the rainfall. Light induced degradation loss. LED loss occurs when the PV modules are exposed for very first time to the sun. The modules are made of silicon which is doped with N-type or P-type boron. When the modules are exposed to the sunlight, oxygen impurities in silicon react with doped P-type boron or gallium. It mainly affects the performance of module. Solar panel loss. Solar panel loss is also known as module rating loss or module nameplate rating loss. It accounts for the difference in stated power of module from a data sheet compared with how it actually performs at standard testing conditions. Now that in the module data sheet the positive tolerance and negative tolerance is always mentioned. Power tolerance is a measure of electrical power a solar panel can produce above or below its rated capacity at any time. For example, a power tolerance of negative 5% over positive 5% on a 100-watt panel would mean the panel could produce 95 watt to 105 watt under normal atmospheric conditions. Mismatch loss. Mismatch loss refers to the losses caused by slight differences in the electrical characteristics of the installed modules. It occurs either due to the different operating conditions or different internal characteristics of the cell. This results in a net decrease in power in this string. For example, series and parallel mismatch, different orientation of the modules, etc. Module degradation loss. The PV module degradation leads to the reduction in solar panel output over time. NRER research has shown that solar panels have a medium degradation rate of about 0.5% per year, but the rate could be higher in hotter climates. A good quality solar panel will have low degradation rates that won't affect the performance of your system too greatly. Ohmic wiring loss. Ohmic losses represent the voltage drop across the circuit. According to Ohm's law, the voltage drop across a circuit is directly proportional to the current flowing in the circuit. The losses faced by the circuit due to this resistance are known as ohmic losses. In circuits, several components can cause a voltage drop, including resistors. Wires have a small amount of internal resistance. The internal resistance depends on the thickness of the wire as well as its length. It is directly proportional to the length of the wire and inversely proportional to the area of cross section. Therefore, size of cable should be directly proportional to the current passing through it. Connection loss. Connection loss captures resistive losses across wiring connector and diodes. This loss can be avoided as most solar panels contain bypass diodes. The bypass diodes are connected in parallel with solar panels. It creates a path for the current to flow around them in case the panels become faulty. System availability loss. This loss generally takes place in on-grid and hybrid solar system. As the name suggests, this loss occurs when there are grid outages, inverter shutdown or failure. Due to the unavailability of the grid, the power doesn't get exported, leading to the loss of power. Potential induced degradation loss. Potential induced degradation loss occurs when the PN junction of cell gets destroyed due to the cracks on the module. Moisture gets inside the modules, which leads to the leakage in the conductivity of the cells. Charges that should go to the inverter gets deposited on the aluminum frame. Gradually solar cells become inactive, which leads to the losses. Inverter loss is the DC to AC conversion. This loss occurs when the inverter converts the DC power to the AC power. This loss depends on the inverter efficiency, which can be described as how well a solar inverter converts DC energy into AC energy. Inverter clipping loss. This loss occurs when the output from the direct solar panels DC at their maximum power output or maximum power point is greater than the amount of DC power the inverter can convert. The amount of energy production lost or clipped compared to what the system would have produced if it had not been limited by the inverter rating is called inverter clipping. Don't worry about all these losses. We already take these losses into consideration before promising you the amount of energy your solar plant will generate.